Hello, my name is Akash Samantha and today I'm going to demonstrate my computer project, which is an alarm system. It uses the Python programming language to control an Arduino board using an API. This can be implemented in many ways. Examples include banks, safes, lockers, or door security. It essentially uses the onboard sensors to detect an intruder nearby and sounds an alarm. If the intruder gets closer to the safe, the alarm gets significantly louder and more intense. Let us now take a closer look at the system with its inputs and outputs. We have the LED buzzer, OLED display, LCD RGB display as outputs, and the button, the light sensor, and the 3-axis accelerometer as inputs. We also have the console input and output. The reason why a light sensor is used rather than an ultrasonic distance sensor module is because a distance sensor can be too focused in one particular field of view. The idea is analogous to the Kepler Space Telescope, which uses light in various electromagnetic spectrums to detect planets outside our solar system. Put it simply, when a planet moves across a star, the brightness dips, which can be used to measure the distance from its star, the size of the planet, and even what type it may be. Alright, enough talking. Let us see the system in action. When the program first starts, it prompts the user to either arm the system, calibrate the system, or quit. It is important to calibrate the system each time lighting conditions change. The system needs to know what is high and what is low. It automatically determines the sensitivity and threshold values for the alarm. Perhaps this might be a caveat for using a light sensor. We just need to give it a couple of seconds here. Note that if a user does not choose to calibrate, the sensor will default to a stored value. This may cause the sensor to be extremely sensitive or not sensitive at all, based on the current lighting environment. Alright, now we can arm the system. First, the system asks the user to set a pin which is at least 4 digits long and contains numbers only. The user may choose to give no pin at all. Confirmation is asked in both cases. Now the system is armed. Let's trigger it by coming closer to the board. I will just hover my hand closer for this. Notice the various modes of alarm levels. If I touch the safe, it will trigger the highest level alarm. The system asks the user to hold the button to disarm. The pin code entered earlier will be needed. The system will not stop buzzing unless the correct pin is entered. Note that if the user had not opted for a pin, then the system will disarm immediately after the button is pressed. After the system is disarmed, it gives 5 options. You can rearm the system, change the pin, view the recorded data, recalibrate the system, or quit. Let us view the recorded data. A window is shown with 2 graphs. It shows the light sensor and the threshold values, as well as the accelerometer values. The graphs let the user know exactly how the alarm was triggered. In this case, the light sensor values reached a minimum threshold value. Okay, let us now try changing the pin. If we try to enter the pin incorrectly 3 times, the alarm gets triggered again. Okay, let us now disarm the alarm and change it to a blank pin. Alright, I will now rearm the system, but this time I will move the board. There we have it. Let us check the graph again. We now see that the accelerometer value has crossed the threshold value. Other features of the system include pin verification, a self-contained user interface, and a goodbye message upon exiting the program. So I hope you liked my project, and thank you for watching.